Okay, good afternoon. Welcome to the class of antenna and wave propagation. Today we will start with the topic of the electric flux density and the Gauss law. This lecture mainly corresponds to the related to the subject, that is antenna and wave propagation, and the subject code is the KEC 603. So first of all, we will talk about the electric flux density. So as we know that the electric field intensity, electric field intensity is given by this. When this electric flux density is dependent upon the permittivity of the medium, then the another vector will be formed, that is a D vector, which is shown by, and this one is the electric flux density. So electric flux density gives the relationship between the permittivity of medium and electric field intensity. Clear? So the new vector will be formed, that is D vector, that relates the medium and the electric field. So D equals to, if I say permittivity is of that medium is epsilon, D equal to epsilon into my electric field. So this is the, now if I say this is a surface, and number of field lines are passing through it. So the number of field lines passing perpendicular to the surface, that defines the net outward flux from this surface, and that is given by the net outward flux is given by the D dot ds, or integration you can say, or you can also say D multiply में area. So net outward flux means the total number of lines passing through this surface will be equal to the electric flux density multiply में area. Clear? So electric flux density D equal to epsilon into में capital E. So for the point charge we know that the electric field intensity is equal to 1 upon 4 pi epsilon q upon में r की पावर 1 by 2 r12 का होल स्क्वायर a की पावर r12 is a, let's say this is the origin and this is point q1 charge and this is point q2 charge. So this is r1 and this will be r2. So r12 will be the distance between these two. Clear? So electric field charge equal to 1 upon 4 pi epsilon q upon में r12 का whole square into में a की power r1 by 2. Clear? So flux density will be equal to D equal to epsilon into में E vector. Just put this value, epsilon into में E vector is equal to, as charge is in the air, that's why we have promoted epsilon naught q upon में 4 pi epsilon naught into में a की unit vector a cap into में r12 का whole square. So this epsilon will be get cancelled out and you will get the electric flux density at point P equal to 1 upon 4 pi q upon में r12 का whole square a cap r12. So we will discuss about the electric flux, means how much the flux is passing through the surface. If I say this the case number 1, for the case number 1, if I say this is a surface and this surface is like this one, and the electric field lines are passing through it, this one, these are the electric field lines are passing through it. So as we know that this is the surface, so its unit vector will be in this direction, S cap. So as E will be, electric field will parallel to the unit vector S cap, so angle between these two will be 0 degree, and this S vector is equal to what? A cap S. The surface unit vector will be like this one. If I say this is a surface, so surface unit vector will be this one, and electric field are passing through this, so both are will be parallel to each other. First point is this one. So the case 1 represents the number of electric field lines passing through perpendicular to a plane or surface. Perpendicular to a plane. Why? Because if I say this is a surface and the fields are passing through it, fields are passing, means the surface and these field lines are 90 degree to each other. But if I say surface field lines and the unit vector of this surface, both will be perpendicular and both will be parallel to each other. So the flux will be equal to, passing through will be equal to electric field lines multiply में its area, or we can say dot product will represent the psi E equal to E dot A into में cos theta, and this theta represents the angle between the A cap S or surface unit vector and electric field. Clear? So in that case you may say that cos theta both are parallel, theta equal to 0 degree, then that comes out to be 1, that psi E equal to, will comes out to be E into A. Now case number 2, if I say the surface is like this one and the fields are like this one, surface are like is like this one, fields are like this one, so they make some angle between two. So this is a surface and field lines are passing, though they make some angle. Clear? And surface vector is in this direction, and the field lines are in this direction, so they both make some angle, that is theta. So in that case psi equal to E dot A into में cos theta. Clear? And theta is the angle between the E vector and the A vector, that is A cap S, you can say, when joined tail to tail. Clear? So we can also say that total flux, if I consider the permittivity, then total flux passing through this, then I can say electric field density multiply में area, that is equal to D into में A into में cos theta. Now see, let E field is a constant throughout the surface, then psi E equal to E into में A cos theta, E into में E dot A, that is E A into में cos theta, or this can also present in terms of electric flux density, this is D vector multiply dot A vector, and this is equal to D into में A into में cos theta. So this psi E, this flux is always comes out to be scalar quantity, because there is a dot product and the resultant of the dot product is always a scalar quantity. So let's say, take a numerical, let's say this one is the surface, this one is the surface, and field lines are passing through it. These are the field lines are passing through it. So if I say the angle between these two, if I say the angle between these two is 60 degree, you will say that the surface is like this one and field lines are passing through this one. So they make some angle, that is 30 degree to this one and 60 degree to this one. Then we have to calculate the flux of D vector means electric flux density crossing through an open surface is defined by what? As we know that D equals to total flux passing through this surface will be equal to D dot A vector. Clear? And you will see here this D dot A vector comes out to be D into A into cos theta. Now this A is the area of this surface, that is equal to pi into r square, and D is the angle between these two means A vector. If I say surface vector is this one, A vector will be there, and the fields are passing through this like this one. So angle between these two means A vector in this direction and the electric fields are passing through this one. So angle between these two is equal to 60 degree, because this is a cap S and this is a electric field. So will be cos 60 degree, and this put the value of cos 60 degree, D equal to pi into r square into cos 60 degree, you will get the total outward flux from this surface. Clear? Now then take a next question. If I say this is a surface, this is a cube, and field lines are crossing through this surface. Field lines are crossing through these surfaces. So calculate, if I say the side of each cube is A, so calculate the net outward flux of E vector passing through a closed surface S. So net outward flux will be equal to what? As there are 6 surfaces, as there are total 6 surfaces, so net outward flux, that is equal D dot ds will be equal to what? Surface 1 D dot ds plus surface 2 D dot ds plus surface 3 D vector dot ds vector plus surface 3 plus में surface 5 and similarly surface 6. So these two surface S1, let's say S1 and S2 means top and bottom surface. Let's say this is top surface and this top surface is, let's say if I say this is a top surface and this is a bottom surface. For the top surface you will see here that the flux fields are passing through this like this one, and unit vector of this surface means for the top surface is like this one. The both will be a 90 degree to each other. So for the top surface E dot A equal to EA cos theta, that is EA into a cos 90 degree, that comes out to be 0. Similarly for the bottom surface, flux unit vector for this bottom surface will be like this one, and the fields are passing with both will be 90 degree to each other. For the bottom surface, the flux density passing through these two surfaces will be equal to 0. For the front surface, you will also see electric field lines are passing through this, and the flux unit vector will be like this one. Both will be 90 degree to each other. So front and the back surface, cos EA into my cos 90, that comes out to be 0. Now for the left surface, if I say for the left surface, this is E vector, electric field are passing through this one, and surface unit vector will be also like in this one. So angle between these two will be, in one case will be equal to 0, in another case will be equal to 180 degree. So when fields are for this surface, if I say for this surface, right surface means for this surface both will be in the same direction, the angle between these two will be equal to 0 degree. So E electric field into my area of surface is equal to A into my A cos A square into my cos 0, that comes out to be EA into my square. And for the left surface, the electric field surface unit vector is in this direction and field lines are passing through this. Both will be equal to angle between these two. One is in this direction, another in this direction. and angle between this that cos 90 degree, and that comes out cos 180 degree, that comes out to minus EA square. If I take the sum of all these in these equation, you will get 0 plus 0 plus 0 plus 0 plus में EA square minus EA square. Overall net outward flux will comes out to be 0. Now case number 3, if I say area vector is not constant, let's say this is a surface, this is a surface and fields are passing through like this one. So at every point you will observe that at every point electric fields are in this direction, but every point area vector is not constant. So for that cases, if you want to calculate the total outward flux, yeah, total outward field lines passing through this surface, how it can be calculated? Take a small surface area, of value of having surface area ds, and its unit vector will be like this one. So angle between this electric field and this unit vector will be, let's say, comes out to be theta. So so total flux passing through this small surface will be equal to d psi small flux, and this d psi will be equal to what? Electric field multiply में dot product of E dot ds, and this is equal to, so to calculate the total flux passing through this one, total flux will passing through this one will be equal to what? Surface integral of E dot ds, surface integral. So here I am telling this psi represents the flux, and here I am telling this phi represents the flux. If I say this is a flux and this one is also flux, psi is also so the net outward flux through the whole surface will be closed integral of the E dot ds, or you can say closed integral of d vector dot ds vector. So now come to point, that is Gauss law in point form. So if I say this is a surface, and field lines are passing through this one, these one. So total flux passing through this one, Gauss law says that total flux passing through this one will always comes out to be equal to the total charge enclosed by this surface. So net outward flux, that is represented by, as we know that in the previous slide we have discussed that net outward flux is represented by d vector dot ds vector, and Gauss law represents that net outward flux from the surface always comes out to the total charge enclosed by that surface, that is equal to q enclosed. So surface integral, closed surface integral d dot ds comes out to be q enclosed, and this, how much charge is present in the surface? If I say this is a line and this line consists of number of charges. So if I say, if I want to calculate how many number of charges will be present here, will be equal to what? Will be equal to what? How number of charges present per unit line, per meter means that is rho L multiply में length of this line. Clear? So total charge will be equal to this rho L equals to line charge density per मीटर मल्टीप्लाई में लेंथ. और for another theorem you can also say that if I want to say take the differential length, that is dl, and this dl, if I want to calculate the number of charge present in this whole line charge density, that is q, then this q will be equal to what? dq means total charge present in this line, that is rho l into a dl, and this q comes out to be integral of rho l into a dl. Clear? So this q enclosed will be rho l into a dl, and similarly for the surface, that is will be equal to open surface integral rho s into a ds, that is surface charge density, per meter square, and this is the, if I say the surface is volume, closed surface forms a volume, that is equal to volume charge density. So apply the divergence law. As we know that apply the divergence law, we know that apply the divergence law. On putting a divergence law, you will see that on applying the divergence law to this one, that will be equal to now see this one, this equation, equate number 1, equate equation number 1, 2 and equation number 2. So we will see that del dot D comes out to be volume charge density, that is the Gauss law in the point form, and this rho will represent the volume charge density, and for the source free region, this del dot D volume charge density for the source free region rho v comes out to be 0. For the source free region, del dot D vector is equal to 0. So due to the so here we have discussed about the starting of the Gauss law, basic concept of the Gauss law in the point form, and in the next lecture we will continue with the Gauss law and the application of the Gauss law. So you will see here principle of electromagnetics by Matthew N.O. Sedico. Thank you.